Good evening, sir.
Good evening. Okay, so most of you guys are here. I hope you all practiced Aldol condensation from the last lecture. Now, right? Cannizzaro reaction. Cannizzaro reaction, it is shown by those aldehyde and ketones which do not have any alpha hydrogen. Okay, it is right. Shown by aldehyde and ketones with no alpha hydrogen. With no alpha hydrogen. Okay, right, next. In this reaction, one molecule is oxidized to carboxylic acid and another is reduced to alcohol. Okay, so for example, you have HCHO, acetaldehyde, reduced to alcohol is made in presence of concentrated alkali such as. Good evening. Okay, so if you have, for example, HCHO, formaldehyde does not have any alpha hydrogen, right? In the presence of concentrated potassium hydroxide, one formaldehyde will change into CH3OH alcohol and the other will be HCOOH, formic acid. But it will not be HCOH right now because KOH is a base. So it will be in COO negative, K positive in the salt state. Similarly, you have benzaldehyde. Benzaldehyde also does not have any alpha hydrogen, right? This is the carbonyl carbon connected to carbon, which is not having any alpha hydrogen. Now, if you add concentrated KOH, then you will get benzyl alcohol, benzene ring, CH2OH, and you will get benzoic acid. Benzene ring, carbon with OOH. But it will not be OH again because we have potassium. It is a base and you will get it in carboxylate ion form. COO negative, K positive. Please write this down. Then guys, yes or no, please tell me.
1 minute. 10, sir.
Okay. Right, next. Electrophilic aromatic substitution. Electrophilic aromatic substitution. Now here you will write aldehyde and ketones are deactivating meta and meta directing group. Deactivating and meta directing. Okay, right, next line. Substitution occurs at meta position. Right here. First of all, we will look at benzaldehyde and then we'll look at acetophenol. So benzaldehyde, CHO. Okay. Now it will show three different electrophilic aromatic substitution reaction. Two of them, sorry, only one of them is there in your NCERT. The last one of only one of them is there. Two are not present in your NCERT, but write all of these. These are typical electrophilic aromatic substitution reactions. So you have Cl2 in the presence of FeCl2, sorry, FeCl3. Then you will have concentrated HNO3 in the presence of concentrated H2SO4. At last, you will have concentrated H2SO4. So in the first case, you will get a chlorine in the meta position, CHO, chlorine here, only one product. Similarly, here you will get NO2 in the meta product. There is CHO. Last case, you will get SO3H in the meta position, sulfonation. Very similar reaction happens with acetophenone only. Okay, acetophenone also gives similar reaction, but instead of CHO, you will have COCS3. Have C double bond O CH3. तो इसको कैसे लिखते हैं? COCH3. Benzene ring attached to carbonyl carbon. Here also you'll have COCH3. Here also you'll have COCH3. This is benzaldehyde. Acetophenone. This is acetophenone. Let me know once you're done. Anyone still writing? Is there anyone who is still writing? No?
Yes, sir. Done, sir.
Right, next, guys. So aldehyde and ketones is completed. Right, next, method of preparation of carboxylic acid. Right here, number 1, oxidation of 1 degree alcohol and aldehyde. Oxidation of 1 degree alcohol and aldehydes. Okay, so if you have 1 degree alcohol, you use an oxidizing agent, you will get aldehyde. Okay, and then the oxidizing agent, a strong oxidizing agent agar hai, then you will get directly now carboxylic acid. Sometimes I will write carboxylic acid as Ca. Okay, C dot A dot carboxylic acid. So that means 1 degree alcohol directly to carboxylic acid. You will use 1 degree alcohol. It uses strong oxidizing agent to get to carboxylic acid. What are the strong oxidizing agent that you can use? You can use K2Cr2O7, or same thing as Na2Cr2O7. You can also use KMnO4. And the last one is important, CrO3 in the presence of acid H plus. H2SO4 हो सकता है आपके पास यहाँ पे. Okay, this is known as Jones reagent. ठीक है, reagent वगैरह के नाम है, then it is going to be important. This is Jones reagent. Right, next. Similarly, aldehydes can be converted to carboxylic acid using strong and mild oxidizing agent.
So,
Yeah, tell me.
carbonic acid using
Mild oxidizing agent, MILD. माइंड में अगर आपको ऑक्सीडाइजिंग एजेंट की एग्जांपल लिखना है, फॉर एग्जांपल silver oxide is a mild oxidizing agent, and then you can have what else? If you have dilute nitric acid, okay, then that is also going to be a mild oxidizing agent. Right, next. From alkyl benzene. Okay, so now in alkyl benzene, doesn't matter what is the length of the alkyl chain, even if you have 2, 3, or 4, doesn't matter. You will use KMnO4 with heat and then KOH. Since it is done in the basic condition, you have alkaline KMnO4 with heat, you are going to get COO negative. Further hydrolysis in the presence of acid, H3O plus, it is going to give you benzoic acid. For example, you have toluene, you want to convert this to benzoic acid. First step, you will have alkaline KMnO4 with heat. Secondly, you are going to give it H2O in the presence of H plus. You will get benzoic acid. After alkyl benzenes, you will write from nitriles and amides. For example, you have R, C triple bond N. If you just add water to it, in the presence of H plus or OH negative, acidic condition or basic condition, acidic hydrolysis or basic hydrolysis, you will get amide. That is R, C double bond O, NH2. After this, if you add again H plus or OH negative in the presence of heat, you are going to get and heat, you will get R, C double bond O, and OH, the carboxylic acid. So here you have CONH2, H plus and heat, you will get 1, 2, 3 carbon atom, and this will be COOH. Similarly, if you have CONH2, H plus and heat, the benzene ring will be as it is. It will be converted to COOH. If you have nitrile, for example, CN, first step H3O plus, second step H plus in the presence of heat, 1, 2, 3 carbon atom, COH. Or even if they just give you H plus and heat, because in both of the cases, first case में आपके पास acid है, second में भी acid है, but you can set heat. If you have nitrile and they give you heat plus H plus, then it is going to convert to carboxylic acid. Can everyone listen to this me? Anyone still writing? No? Okay. Right, next, fourth one from Grignard reagent. Now, in this case, please listen very carefully. You have RMGX plus, what is this? This is CO2, carbon dioxide. Okay. What do we have here? Here we have carbon dioxide. So as you can see, this R is going to have delta negative because it is attached with magnesium. This R is going to attack on the carbon. Okay, this carbon atom will be what? Very much delta positive because it is attached with oxygen atom on both the sides. As soon as it will be attacked by the R, you will get O negative here, which will give you this carbon atom, this R, which attacked on the carbon atom. This carbon atom will be having double bond O, and there will be one O negative. And this O negative will be attached with OMGX. Okay. After this, you just add water, and you will get R, C double bond O, and OH. Okay. So for example, if you have 1, 2, 3 carbon atom MgX plus, आपके पास इस तरह से अगर दिया रहेगा, these are two steps. CO2, the first step is done in dry ether because we have Grignard reagent. Second step may we add water to it, and you will get water in the presence of H plus लिख लीजिए, and you will get, यहाँ पे 2 कार्बन है, 1 कार्बन डाइऑक्साइड का, so total 3 carbon atom. Third carbon atom will have COOH. Okay, so this reaction and the above reactions are important. Please write this down because उसमें देखिए क्या हो रहा है ना, you will get 1 carbon more. यहाँ पे भी देखिए you are getting 1 carbon more, 2 carbons, and the result is with 3 carbon atoms. Carboxylic acid is having 3 carbon atoms. Is right? Carboxylic acid formed will have 1 carbon more than the Grignard reagent. This reaction and the previous reactions are important in conversions. Please see how. For example, if I have to convert ethanol to propanoic acid, how will I convert? I can use both this method and the above method. Ethanol, OH, and I have to convert this to propanoic acid, 1, 2, 3 carbon atoms and COOH. So first of all, I will do SOCl2 or anything to get it, to make it haloalkane. So I will get 1, 2 carbon atoms and Cl here, which then I will convert to, react with Mg, and I will get 1 carbon, 2 carbon, which is attached with MgCl. Mg will do an insertion reaction in the presence of dry ether, and I will get RMgCl. Now in this case, I have to do first reaction with CO2, second reaction with H3O plus. I will get the carboxylic acid as in this case. Another thing that I can do is, I have the same reagent. I can use the same SOCl2 and I would react this with KCN. After reacting it with KCN, I will get 1 carbon, 2 carbon and CN. After getting CN, in the presence of H plus and heat, I will convert this nitrile to 3 carbon atoms and OOH. Okay, so both of these methods are important when you have to go from less number of carbon atom to 1 more carbon atom. This is known as ascent of carbons, है ना? Ascent होता है, ascent का मतलब क्या होता है? Ascending का मतलब एक ज्यादा, ठीक है? Ascent of carbon वाले जो भी conversions होते हैं, in those In those conversions, these are important reactions. The reaction of Grignard reagent to get carboxylic acid and the reaction of nitrites to get carboxylic acid. Write this fast. Let me know if anyone is still writing. If not, then write the fifth method of preparation is from acyl halide. These are easy reactions, okay? See, you have R, COCl in the presence of just water or water in the presence of acid, you will get RCOOH. But if you do the same reaction in alkaline medium, then first of all, you will get RCOO negative because it is alkaline. And then when you add H plus, you will get RCOOH. Okay, so bas kya na? Hydrolysis. Okay, hydrolysis of acyl halide gives carboxylic acid, nothing else. Sixth one from anhydrides. What are anhydride? Anhydride have a general structure in which you have R, C double bond O, bonded to O, then C double bond O, and then bonded to some R dash. Okay, when we do hydrolysis for this, what happens? One of the R group, it will make this here, it is going to make one carboxylic acid, and this here is going to make another carboxylic acid. Okay, ऐसा आप समझ लीजिए. Hydrogen gets to this oxygen and OH gets to the another fragment. So you will have R, C double bond O, OH plus R dash bonded to C double bond O, bonded to OH. Right, for example, you have CS3, C double bond O, bonded to oxygen, C double bond O, and this is bonded to phenyl group. Plus H2O, it is going to give me, first of all, you will have CS3, C double bond OH, plus then यहाँ से start कीजिए benzene ring, directly bonded to C double bond O, followed by OH, benzoic acid. Right, the seventh one from esters. This reaction we have seen in the reactions of alcohol. Okay, for the method of preparation of alcohol, you have R, C double bond O, and OR dash. Again, same thing, H3O plus, acidic hydrolysis. You will get R, C double bond O, OH plus R dash OH. Okay, so this makes the carboxylic acid, and this part, it makes the alcohol. बताइए यहाँ पे बेंजीन वाला कार्बोक्सिलिक एसिड बनाएगा या फिर मिथाइल वाला? टेल मी. Red fragment will make the carboxylic acid, or this one, the green fragment. कौन सा बनाएगा बताइए? The red or the green one, which will make कार्बोक्सिलिक एसिड. प्लीज देखिए यहाँ स्ट्रक्चर देखिए, कलर मत देखिए ऊपर वाले से. यहाँ पे कार्बोक्सिलिक एसिड कौन बना रहा है? दी आर इज कनेक्टेड टू सी डबल बॉन्ड, है ना? तो ये याद रखिए, द वन विच इज कनेक्टेड टू सी डबल बॉन्ड ओ, दैट इज ओनली गोइंग टू मेक दी कार्बोक्सिलिक एसिड. टेल मी हियर, द रेड और द ग्रीन?
Red.
बोल बोल के सब कुछ स्कीम बता दीजिए आप. आकिंजा, चैट है ना, चैट में लिखिए आंसर. This is for Kinza. Done everyone? Yes or no? Please tell me.
Yes, sir.
Right, next.
So 1 minute.
आप ही ने आंसर किया, आप ही नहीं. Kinza, that was you, right?
Yes, sir. उस टाइम सोची थी कि जवाब क्या होगा. So I didn't write.
अच्छा.
Done, sir.
Right. Physical properties of carboxylic acid. मतलब अब बिल्कुल आखिरी हो गया है ना. इवन इन ऑर्गेनिक केमिस्ट्री. बताइए तो फिजिकल प्रॉपर्टीज में क्या क्या पढ़ते हैं हम लोग?
Boiling point, melting point.
क्या अक्षय?
Boiling point, melting point, solubility.
हाँ ठीक है, मेजरली बॉइलिंग पॉइंट पढ़ते हैं, मेल्टिंग पॉइंट नहीं, क्योंकि मोस्ट ऑफ द ऑर्गेनिक मॉलिक्यूल्स दीज आर नॉट सॉलिड्स. ठीक है, तो बॉइलिंग पॉइंट और सॉलिबिलिटी दो ही चीज पढ़ेंगे. और दोनों में एक वर्ड जो बहुत ही इंपॉर्टेंट है, व्हाट इज दैट वर्ड? क्या डिटरमाइन करता है? सॉलिबिलिटी. आल्सो सॉलिबिलिटी वेयर? सॉलिबिलिटी इन
Hydrogen bonding.
हाइड्रोजन बॉन्डिंग तो इंपॉर्टेंट वर्ड है. सॉलिबिलिटी कहाँ पे देखते हैं, किसके अंदर? पानी के अंदर सॉलिबिलिटी, राइट?
Yes.
So these are the only two things. और जो इंपॉर्टेंट चीज है यहाँ पे हाइड्रोजन बॉन्डिंग. ठीक है, प्लीज राइट. कार्बोक्सिलिक एसिड हैव हाइड्रोजन बॉन्डिंग, है ना? कार्बोक्सिलिक एसिड के पास हाइड्रोजन बॉन्डिंग होता है, and that is why it is having higher boiling point than comparable aldehyde and ketones and also alcohols. Please write. Carboxylic acid have higher boiling point corresponding का मतलब बताएगा कोई? What is the meaning of corresponding?
Like propanoic acid corresponding is propane.
हाँ, तो ऑलमोस्ट इक्विवेलेंट
और
मोलर मासेस
propanol
होंगे
और
जिनके
propanol.
कंपेरेबल मोलर मासेस. हाँ करेक्ट. ठीक है, आसपास मोलर मासेस होंगे जिनके ना, उन दोनों को कंपेयर किया जाता है. नॉट अकॉर्डिंग टू द कार्बन नंबर. प्लीज याद रखिएगा, नॉट अकॉर्डिंग टू द कार्बन नंबर. अगर आप कंपेयर कर रहे हैं, फॉर एग्जांपल 1 2 3 4 कार्बन आटम है यहाँ पे, है ना? दिस इज योर ईथर. लेकिन इसके करस्पॉन्डिंग जो आपका द करस्पॉन्डिंग एल्केन फॉर दिस विल बी this carbon atom, this pentane, because if you take butane, then butane is going to have much lower molar mass than the ether. ठीक है, because butane में 4 कार्बन है लेकिन सारे हाइड्रोजन है. Here you have 4 carbon atom but one is oxygen. Okay, so comparable molar masses. Right, next. Corresponding aldehyde ketones and also alcohols. And also alcohols. This is due to more extensive hydrogen bond. How does the hydrogen bond looks? C double bond O, OH, and here you have okay. So this is one molecule. This is another molecule. Okay, and these two have hydrogen bond like this. This hydrogen bond is so strong कि अगर आप ना कार्बोक्सिलिक एसिड को बॉईल कीजिएगा तो बॉईल हो के ना आई मीन दिस कंप्लीट डाइमर फॉर्म इट इवैपोरेट्स. ठीक है, कार्बोक्सिलिक एसिड अलग अलग भी नहीं हो पाते दो. So this exists in the same form in vapor state and also in aprotic solvent. एक सवाल आता है, what is the structure of carboxylic acid in gaseous form or vapor state? Dimer of carboxylic acid. So what you will write this structure and then you will see that in vapor state carboxylic acid exists as a dimer. Done everyone? Yes or no, please tell me.
Yes.
Right, next. Aliphatic carboxylic acid are soluble in water. As they form hydrogen bond with water. How will they form hydrogen bond? Okay, so it has hydrogen bond between एक तो आपका both the hydrogens of water is having hydrogen bond and also the hydrogen. ठीक है? Right here solubility decreases as the number of carbon atom in alkyl chain increases. In alkyl chain increases. Right, next, benzoic acid is not soluble in water. क्यों? क्योंकि alkyl chain में 6 कार्बन बहुत बड़ा हो गया, right? Benzoic acid is not soluble in water due to large alkyl group. Benzoic का spelling सही कर लीजिए please. So be benzoic. Right, next, carboxylic acid are soluble in organic solvents such as benzene, ether, alcohol, chloroform, etc. Now, write chemical properties of carboxylic acid. Chemical properties of carboxylic acid. In this, the first acidic character, it is the most important chemical property. Please write. Number 1, acidic character. In this, first of all, we will look at the reactions, and it shows reaction with alkali and metals. And in metals, active metals. Okay, so please write. Number A, reaction with metals and alkali. Here you have RCOOH plus any of the wedding elements, Na, it is going to give you RCOO negative, and it will liberate hydrogen gas. If you have carboxylic acid with alkali sodium hydroxide, you are going to get RCOO negative plus water. If you have RCOOH with Na2CO3, you will get again the carboxylate. Okay. यहाँ पे COO negative है ना? It will also contain here Na positive. ठीक है ना? It will be balanced by, the negative charge will be balanced by Na positive. Okay, so here also COO negative, Na positive, plus you will get water and carbon dioxide, H2O plus CO2. So these are the reaction that it shows. In all of them, it is getting the sodium salt of carboxylic acid. Okay, sodium carboxylate. If you use potassium, then you will get potassium salt of carboxylic acid, potassium carboxylate. Now, its acidic strength, right? The B part. Its acidic strength. So we determine the acidic strength by the equilibrium constant of the acidic reaction. If I have RCOOH plus water, then it is going to give me H3O plus. Okay, this acid H plus is going to be liberated and it will be attacked by the water's oxygen atom. You will get H3O plus. Plus, we will get the conjugate base, that is you will get R bonded to carbon, double bond oxygen, single bond oxygen, and a negative charge. So now this is going to do resonance like this. O negative will go here. This pi bond will go to oxygen atom, giving you two resonating structure. O negative, and now here double bond O. Now due to this resonating structure, we can say that the carboxylate ion is stable. And since it is stable, it can easily give out the H plus ion. So H plus ion को बाहर जाने में कोई दिक्कत नहीं. Carboxylic acids will say, okay, fine, H plus you can leave. Even if I get a charge, negative charge, I can bear that negative charge because I have resonating structures. I have resonance, and that is why resonance will give me some stability. So H plus ion, you can please leave. That means it is having some acidic strength. Please write carboxylic acid dissociate in water. Carboxylic acid dissociate in water to give resonance stabilized. This is important, ठीक है ना? Resonance stabilized. Resonance stabilized carboxylate ion and hydronium ion. Hydronium ion क्या है आपका? H3O plus. ठीक है, that is why when they will say ना, how is carboxylic acid acidic in nature? Why is it acidic in nature? Then you will say because it dissociates in water to give resonance stabilized carboxylate ion and hydronium ion. Now, how much acidic it is? ये तो पता चल गया acidic है. कितना acidic है? That we will understand by K equilibrium, which is the concentration of product divided by the concentration of reactant. Now, concentration of product is, in the product we have H3O plus का concentration, plus we will have the concentration of RCOO negative. In the reactants we have the carboxylic acid RCOOH, and then we have H2O, the water molecule. But since the concentration of water molecule does not change, it is a constant, and K equilibrium is also a constant, so we will put the constant in one side. K equilibrium and H2O, this is going to be equal to the same thing except water. Now water को हमने कहाँ भेज दिया? Left hand side पे. Okay. Now, if I have more product, this K equilibrium will also be high, and this K equilibrium into H2O, in the case of acid, it is known as Ka. This is equal to the same thing. Okay. So as the dissociate ion, if we are going to dissociate more and more, then the product will increase. The amount of product will increase and the Ka will also increase. So if you have strong acid, see what is the definitions? If Ka is high, we have a strong acid. Okay, acidic strength is also high. But we don't use Ka because Ka becomes very large quantity. We rather use pKa. pKa is defined as minus log of Ka. Minus log of Ka. Now, if you have strong acid, then the Ka will be high. ठीक है, अगर K ज्यादा होगा तो minus log K क्या हो जाएगा? और भी ज्यादा कम हो जाएगा. So you will write for strong acids, pKa is low. K मान लीजिए था आपके पास, K था आपके पास 100, ठीक है, और एक में K था आपके पास 10, तो इसका आपके पास माइनस log K, ठीक है. log 100 will be equal to what? 2, and you put a minus sign, minus log Ka, minus 2 हो जाएगा, right? And then here you have Ka that is equal to 10. तो यहाँ पे बताइए, this will be equal to what? minus 1. तो कौन ज्यादा कम है? minus 2 is less. pKa कम है, Ka ज्यादा है. Can all of you see that? Yes or no? Please tell me.
Yes.
ठीक है, so for strong acid, pKa should be lesser. when you have pKa that is less than 1, it is a strong acid and quite strong acid. When you have pKa that ranges between 1 to 5, this is moderately strong acid. Moderately strong acid. If you have 5 to 15, this is a weak acid. And if it is, ये pH नहीं है, please याद रखिएगा, pKa है. If pKa is greater than 15, it is extremely weak acid. All of you done? Yes or no? Please tell me. All of you wrote this? Not, please write. Next. देखिए, एक कंपैरिजन है आपके पास फिनॉल वर्सेस कार्बोक्सिलिक एसिड, which is going to be more acidic. ठीक है, तो यहाँ पे देखिए phenol and carboxylic acid. See, if you have phenol, in the presence of water, it will give you phenoxide ion, O negative plus H3O plus. Similarly, if you have carboxylic acid, RCOOH, H plus, it will give you RCOO negative plus H plus. Now, in both of these things, in phenol and carboxylic acid, the factor which defines the acidic nature is the resonance. Now, if I draw the resonating structure of phenol, not phenol, rather phenoxide ion. Wait a second. You will get double bond O, get the negative charge here. This bond is as it is, this bond is as it is. Moves here, this bond will move here. Double bond O, double bond O, double bond O, negative charge here. This negative charge will move here, this pi bond will move here. You will get negative charge here, double bond O, pi bond here, pi bond here. This negative charge will move here, this pi bond will move here, and then we will get O negative. Now, in this case, as you can see, how many resonating structures are there? Tell me, guys. How many resonating structures? अरे गिन के बताइए कितने resonating structures हैं? How many resonating structures, guys?
5.
Sorry, how many?
5.
5, right? And how many resonating structures in the case of carboxylate ion? How many in the case of, tell me?
2.
2. Which will be more stable than? Phenoxide or carboxylate?
Phenoxide.
But carboxylate is more stable. Why is that? Please. In phenoxide ion, although we have more number of resonating structures, but in this the delocalization is happening, and I am getting some negative charges on which carbon atom? On the carbon atoms. We are getting the negative charge on which atoms? On carbon atoms. And all of these are non-equivalent resonating structures. Okay? If you look at these two resonating structures of carboxylate ion, here also the negative charges in oxygen, here also the negative charges in oxygen. So this is equivalent, first of all. This is equivalent resonance. And secondly, negative charge is always on more electronegative. En is more electronegative oxygen atom. What about here? Here, first of all, it is non-equivalent resonance. And secondly, negative charge. तो ये भी डेल्टा नेगेटिव होगा, इसको भी डेल्टा नेगेटिव कीजिएगा यहाँ पे प्लीज. Negative charge is mostly on less electronegative carbon atom. ठीक है? Therefore we write, therefore carboxylate ion is more stable than phenoxide ion. Hence, carboxylic acid is more acidic than phenol. जिन लोगों ने नहीं लिखा, please write this down. All of you understood this? Yes or no? Please tell me. Why carboxylate ion is more stable?
Yes, sir.
Remember these lines, non-equivalent resonance and equivalent resonance. ठीक है? उसी से आपको पता चल जाएगा कि मेन पॉइंट क्या है. Non-equivalent में देखिए नेगेटिव चार्ज अलग-अलग जगह है. Some mostly it is in a carbon atom. Equivalent it is always in oxygen atom. And obviously oxygen, which is more electronegative, that can bear the negative charge more graciously, right? It can bear negative charge more than the carbon atom. Let me know if you're done. Still writing? Anyone still writing?
Yes, sir.
Please let me know once you're done.
Done, sir.
Now, right, next, effect of substituent. So we did the reaction, we saw the acidic strength. Okay. Now the effect of substituent. Acidic strength में हमने देख लिया कि it is obviously more acidic than phenol. Phenol अभी तक हमारे सबसे ऊपर में चल रहा है. It was the most acidic organic molecule that we saw, but right now we have new winner. Okay. That is carboxylic acid. Carboxylic acid is the most acidic और नाम में ही है ना, नाम में ही क्या acid है. So it is the most acidic of all the organic molecules. Please write C part. अच्छा, pK की अगर बात करें तो pK of carboxylic acid, it lies in this moderately strong acid range. Mostly it is somewhere around 4 point something होता है. ठीक है, depends on what are the substituent, but it lies in the moderately strong acidic group. Right, next. C part, effect of substituent. Now, as we know that the strength of carboxylic acid, it depends on the stability of the carboxylate ion, right? It depends on the stability of carboxylate ion. So please write first point. Acidic strength of carboxylic acid depends on stability of RCOO negative. ठीक है. अच्छा, negative charge को कम करना है, right? We have to what? Delocalize the negative charge. We have to lower the negative charge density यहाँ से oxygen से. So if I have an electron withdrawing group that is attached to R नहीं, that is attached to the carbon which is having the O negative charge. ठीक है. और O negative charge अभी हम लोगों ने देखा कैसे रहेगा. It will be in resonance इस तरह से, delta negative and delta negative. Right. Now if this electron withdrawing group pulls the electron, so density oxygen atom में और कम हो जाएगी. So what I can write? I can write the charge density. Charge density decreases, and what will happen to the stability if the charge is decreasing? Stability will, बताइए stability का क्या होगा, बढ़ेगा या घटेगा?
Increase.
Increase. इसकी वजह से acidic strength increases, and इसकी वजह से pKa
decreases.
Similarly, if you have electron donating group attached to carbon with two oxygens, delta negative and delta negative, it will give the electron, increasing the charge density. Stability will decrease. Acidic strength will decrease. pKa will increase. Right, next, order of electron withdrawing group. ठीक है ना. If you have carboxylic acid में अगर phenyl लगा हुआ हो, pH, that means the benzene ring is attached, तो benzene ring भी क्या करता है, इलेक्ट्रॉन को पुल करेगा अपनी तरफ, right? After that you have iodine which is higher than benzene, then you have Br, then you have chlorine, then you have fluorine, then you have nitrile group. After that you have NO2 followed by CF3. Okay, so if CF3 is attached, then it is the most acidic carboxylic acid. After that you will write which acid in each pair has higher pKa. ठीक है, इस तरह के सवालों का खास ध्यान दीजिएगा, वो पीके पूछ रहे हैं, एसिडिक स्ट्रेंथ का ऑर्डर मत लगा क्या चाहिएगा, ठीक है, बट ऑब्वियसली यू विल आंसर फर्स्ट ऑफ ऑल अकॉर्डिंग टू द एसिडिक स्ट्रेंथ एंड उसके बाद आप पीके का ऑर्डर दीजिएगा. प्लीज राइट दिस क्वेश्चन. यू हैव 4 पेयर्स. चलिए पहले वाले में बताइए, which will have higher acidic strength, A और B? Which will have higher acidic strength, A और B? Those who, I mean, उनको समझ ही नहीं आ रहा क्या करना ना, तो please raise your hand. Raise your hand if you're like completely stuck. पता ही नहीं क्या करना है. A और B, which will have, okay, Akshay has answered. Okay, PK, fine. P में, okay, 4 में, हाँ, okay, yeah, those are correct. What about others? Anyone who does not know what to do at all? Tell me. Atif, Dona, Hamza, Hiba, Kenza, anyone? जिसको अप्रोच करना समझ में नहीं आ रहा हो, तब तो आंसर चाहिए सबसे. प्लीज सेंड द आंसर्स क्विकली. आई विल वेट 1 मिनट ओनली. कम से कम 1 2 3 किसी का भी आंसर आना चाहिए. सारे आंसर्स भेजने की जरूरत नहीं है, किसी एक का भी आंसर कीजिए. आई विल वेट ओनली 1 मिनट. Then I will ask the approach. ठीक है, then I will ask the approach. Okay, Dona, ये क्या है, pKa और acidic strength? I hope you are giving what, pKa or acidic strength? Tell me, Donna. Okay, turn your mic on. Donna, can you please turn your mic on quickly?
Yes, sir.
Yeah. Tell me, what was your approach?
I'm not sure. I just kind of guessed it.
No. What did I say? I asked you guys. अगर नहीं approach पता तो फिर बताइए. Like how, or like और कितना हम clear करके बोले बताइए Donna. What should I say then? If you are still not telling me, sir, I don't know the approach.
No, I thought you were gonna explain after this. That's why
I
was
will
saying
explain after it. नहीं हम छोड़ देंगे मान लीजिए. If I don't explain it, क्योंकि आप लोगों को तो पता है approach.
I'll tell that I don't know the approach.
हाँ, आप तो हमको पता है कि you don't know the approach. But see here. यहाँ तो दिया है ना आपके लिए, right?
Yes, sir.
ठीक है. तो पीके आपको क्या करना है, आप एसिडिक स्ट्रेंथ आप सबसे पहले देखिएगा, एसिडिक स्ट्रेंथ किसका ज्यादा है या किसका कम है. ठीक है. नाउ इन ऑल ऑफ इन दिस केस, फर्स्ट ऑफ ऑल टेल मी, इन ए डू यू सी एनी इलेक्ट्रॉन विथड्रॉइंग ग्रुप? आपको इलेक्ट्रॉन विथड्रॉइंग ग्रुप दिया हुआ है ना? यू हैव द लिस्ट ऑफ इलेक्ट्रॉन विथड्रॉइंग ग्रुप, यस और नो? टेल मी डोना.
Yes, sir.
ओके. नाउ टेल मी, प्रेजेंस ऑफ इलेक्ट्रॉन विथड्रॉइंग ग्रुप इंक्रीजेस द एसिडिक स्ट्रेंथ या डिक्रीजेस एसिडिक स्ट्रेंथ? इलेक्ट्रॉन विथड्रॉइंग ग्रुप होता है तो एसिडिक स्ट्रेंथ ज्यादा होता है या कम होता है?
Electron withdrawing strength increases.
ठीक है. अब बताइए, इन द फर्स्ट वन ए और बी, किसी में भी एसिड, किसी में भी आपको इलेक्ट्रॉन विथड्रॉइंग ग्रुप दिख रहा है? ए और बी किसी में भी दिख रहा है? बताइए. Look at the list and tell me, do you see any electron withdrawing group in A or B of the first pair?
B.
B में है, right? So B will be what, more acidic, yes or no?
Yes.
So acidic strength क्या होगा? B का ज़्यादा. Now tell me, if acidic strength is higher, pKa is higher or lower?
Lower.
तो pKa किसका ज़्यादा होगा?
A का.
और आपने क्या आंसर किया है?
उल्टा.
उल्टा. D में बताइए, सेकंड पेयर में बताइए आप. आपको दिख रहा है कोई इलेक्ट्रॉन विथड्रॉइंग ग्रुप?
A में yes.
एंड D में?
Yes. Wait.
बट किसकी कैपेसिटी ज्यादा है इलेक्ट्रॉन विथड्रॉ करने की?
A का.
क्लोरीन या क्लोरीन? सॉरी,
Chlorine.
देख के बताइए किसकी ज्यादा है?
It's chlorine, no?
अरे फिर
Oh wait, no. F. Yeah. A का.
ग्रेटर देन है ना, फ्लोरीन इज ग्रेटर देन क्लोरीन. ओके, so which will be more acidic?
A.
A will be more acidic.
Yes.
And pK?
B.
अब इसमें बताइए, दोनों के दोनों फ्लोरीन है, राइट?
Yes.
बट दिस फ्लोरीन, द बी फ्लोरीन इज नियरर टू द कार्बोक्सिलिक एसिड, तो ये ज्यादा इलेक्ट्रॉन विथड्रॉ कर सकता है, राइट?
Yeah.
So acidic strength is of B. pK किसका होगा?
A.
Now tell me for the fourth one.
Fourth one. A would be having more strength, acidic strength, and pK value would be for B.
Please write this down, guys. जिन लोगों ने आंसर नहीं लिखा है.
So can you scroll up 1 second? I think I got the order wrong. Okay, sir. Thank you.
Right, next. The second reaction that carboxylic acid gives is formation of anhydride. See, if you have ethanoic acid plus one more molecule of ethanoic acid, okay, so this, it forms water in the presence of H plus and heat, or you can take P2O5 and heat. So what is going to happen? CH3, the carbonyl carbon as it is. Now this carbonyl carbon will be attached with oxygen, and then the rest of the molecule is same. C double bond O and then CH3. So from ethanoic acid, okay, what did we get? Ethanoic anhydride or acetic anhydride. Okay, acetic acid से acetic anhydride. So in general, if you have R C double bond O OH in the presence of P2O5 and heat, it will use two molecules and you will get the anhydride. That means R C double bond O, oxygen with C double bond OR. And the third reaction, formation of ester. So this reaction you have seen in alcohol also. You have COOH plus R dash OH. It gives you ester in the presence of mineral acid. You will get R COO R dash. For example, if you have 1, 2, 3 carbon atoms with carboxylic acid and you have 2 carbon atoms OH, then in the presence of H plus, it is going to give you CH3 and C double bond O followed by O and then 2 carbons, C2H5. For this, please write the mechanism. We start with carboxylic acid. Now, in carboxylic acid, you have oxygen with its lone pair electron. And in acidic medium, this oxygen atom will attack on the H plus and you will get R double bond O bonded to hydrogen with a positive charge, and it will have OH. Now this carbon atom will be delta positive because it is connected with one oxygen here and the other oxygen here. So the R dash OH alcohol here, its oxygen atom with its electron pair will attack on the carbon atom which is doubly bonded with the oxygen. Now you will get R. As soon as this will attack, this pi bond will break and neutralize the oxygen atom. That carbon atom, which is having now OH, which has one more OH here. And it is bonded with oxygen, which has R dash, and it also has hydrogen here. Now this oxygen is oxygen with a positive charge because it has 3 bonds. And now this oxygen with its lone pair electron, it will attack on this hydrogen atom, that is known as proton transfer, because this hydrogen will be very delta positive as it is attached with oxygen atom with a positive charge. Now, as soon as this happens, you will get R bonded to carbon, which is already bonded to OH. Now this oxygen atom has 2 hydrogens with a positive charge, and it is very likely to get converted to water. So in the next step, this oxygen atom will leave, okay, with the electron from the carbon bond. So what is going to happen? This oxygen atom will give the carbon atom some double bond, and you will get R carbon atom with a double bond O and a single bond H. And here you will have OR dash. Now this oxygen will get a positive charge because it has 3 bonds. So this hydrogen atom will give the oxygen its electron, and then you will get R C double bond O OR dash. This is the ester. So this complete reaction is just a multiple steps of proton transfers and one nucleophilic addition attack. This oxygen atom acts as a nucleophile. It attacks on the carbon atom. That is a nucleophilic attack. After this mechanism, you will write formation of acid chloride. All of you done with the mechanism? Can I move on? I'm still writing. Still writing?
No, sir.
Okay. So see, acid chloride, you will recognize few of the familiar reagents here. Okay. So you can use 3 reagents to convert carboxylic acid to acid chloride. You just need to change this OH to Cl ना, तो हम लोग at least उसी तरह का रिएक्शन होगा जैसे आपका हैलोएल्केन में हो रहा था, अल्कोहल से हैलोएल्केन, तो PCl5 यूज कर रहे थे हम, and you will get what R C double bond O and then Cl here, plus other will be POCl3 byproducts में, and you will get HCl. Similarly, I can use PCl3, same reaction, R C double bond O Cl, same product, plus H3PO3. One more reagent that is very useful, SOCl2, RC double bond O, Cl plus sulfur dioxide and hydrogen chloride. Okay, so all of these reagents are similar, and same thing is happening here also. OH is getting replaced by chlorine atom. The 5th one, formation of amides. When carboxylic acid, if you react this with ammonia, so you have carboxylic acid R COOH plus ammonia. Carboxylic acid is an acid, ammonia is a Lewis base. So this lone pair electron will attack on the hydrogen atom, and you will get R COO negative. And since nitrogen has attacked on hydrogen, nitrogen will get the hydrogen NH4, and this will get a positive charge. Now, once you heat this, water will be removed. Okay, water will be removed. So if you remove water, you will get amide, or C, that is doubly bonded to oxygen. This oxygen atom and 2 hydrogens. So you will remain with RCO NH2. Okay, so if you have carboxylic acid with 3 carbon atoms, the first step it is NH3. Second step it is heat. Then you are going to get, first of all, CONH2, or you can also write this as double bond O NH2. Okay, and this one important reaction is formation of phthalimide. Please write. PHTH, phthalimide. We take a benzene ring with 2 carboxylic acid in the ortho position. React this with ammonia. Both of these get converted to COONH4 positive, COO negative, NH4 positive. Here also you'll get COO negative, NH4 positive. Okay. Now, once you heat this, you will get COONH2, COONH2. Okay. Now, then again on extreme heating, ammonia leaves. यहाँ से क्या निकलता है पहले में? पानी and then ammonia. So 1 hydrogen atom from here and the complete nitrogen and 2 hydrogens from here. So it becomes a ring structure which looks like this. Nitrogen with only 1 hydrogen remaining, and this is C double bond O, and this is C double bond O. This is known as phthalimide. So it is just one more step. यहाँ तक तो हम लोगों ने पढ़ा है amide तक. जब आपके पास amide बन जाए, then you just heat once more, and you will get phthalimide. Done everyone? Yes or no? Please tell me.
Done, sir.
Right, next, the reduction of carboxylic acid. Sixth है ये. For reduction, you can use 3 different reagents. No, not 3, sorry. You can use only 2 different reagents, and both are going to give you 1 degree alcohol. So if you have R, COOH, we can use lithium aluminium hydride. This will give you R, CH2OH, same number of carbon atoms. Okay. After lithium aluminium hydride, you will also need to do hydrolysis, H3O plus. Similarly, in the second reagent, that is diborane, B2H6, the second step you will do hydrolysis, and you will get R, CH2OH. Okay. But please remember, there is another reducing agent which cannot reduce carboxylic acid, that is NaBH4. This will give no reaction. Okay, so only 2 reagents lithium aluminum hydride or diborane. Both of these are giving you what? 1 degree alcohol. Done, guys? Yes, no, please tell me.
1 minute, sir. Done, sir.
Right, next, the 7th reaction, decarboxylation. So when you react sodium salt of carboxylic acid or COONA in the presence of soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide, NaOH plus CaO, and heat it, you will get alkene, and this alkene will not have this one carbon atom. So you will get alkane with one less carbon atom plus Na2CO3. And for example, if you have COOH, NaOH plus CaO, presence of heat. So what will I get? Tell me, guys. What will be the alkane? How many carbons in the alkane? Here we have 1, 2, 3 carbon atoms. So in the product, I will get alkane of how many carbons? Tell me. Look at this and look at this.
2, sir.
2 carbons, na? CH3 plus Na2CO3. Right, NaOH plus calcium oxide in 3:1 ratio is called soda lime. All right, the 8th reaction, Hell-Wohl-Hard. Zielinski reaction. Is also known as HVZ reaction. Okay, it's very easy reaction. You should have at least one alpha hydrogen. So you should have CH2, COOH, and you react this with, first step is hydrogen in the presence of, halogen in the presence of red phosphorus, and second step is water. So one hydrogen on the alpha carbon will be replaced by the halogen atom. Everything else will be same. So for example, you have Cl2, red P, second step is water, 1, 2, 3 carboxylic acid, second carbon में आप डाल दीजिए बस क्या, एक हाइड्रोजन नहीं, एक क्लोरीन. Okay, if you have, let us suppose, COOH, Br2 in the presence of red phosphorus. Second, you have water, COOH, and you will add Br in the alpha carbon. इसके बाद जो है ना, आप एक होमवर्क करके आइएगा, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन ऑफ कार्बोक्सिलिक एसिड. There are two reactions. Of carboxylic acid. चलो. Okay, this is your homework. There are two reactions in NCERT. उसके बाद एक नोट टाइप का भी है, वो खुद से बना के लिखिएगा. Saying that ये एक certain type of electrophilic aromatic substitution नहीं देता है. Why does the